Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So let's continue our lecture on still under the same topic, Introduction to Hypothesis. This is part E, where we're going to discuss about chi-squared test of independence. So previous lecture, we are discussing on hypothesis for numerical variable. Right, for chi-squared test of independence, right, is used to find out whether there is an association or relationship between two qualitative variables. So we are dealing with the qualitative variable. So the null hypothesis is the variable that are not associated. Right, this is a statement for null hypothesis, means always not associated. In other words, they are independent. So when we accept null hypothesis, means that the two variables are independent. So the alternative hypothesis is the variable that are associated or dependent. So this is for qualitative variable. So if we accept alternative hypothesis, it means that there is association between these two qualitative variable, or there is these two variable are dependent. So this is an example of some how hypothesis can be written in chi-square analysis of independence. So first one, we can write whether the null hypothesis there is no association between x and y, variable x and y. Alternative hypothesis, there is an association between x and y. Or we can also say that for null hypothesis, there is no relationship between x and y. Alternative hypothesis, there is a relationship between x and y. Or another way, we can write it in another way. X and y are independent for null hypothesis. X and y are not independent, which is they are independent in alternative hypothesis. Right. So all chi-squared independent tests are right tail tests. They are no longer distribution look like a normal distribution. Right tail test is a skewed to the right distribution, right? It's skewed to the right distribution. So this is a chi-squared distribution, right? So in previous lecture, we are looking into t-test and z-test, right? They are both in normal distribution, but in chi-squared, we are using skewed to the right distribution, which is chi-squared independent test. This is a right tail test. This is starting from 0 until infinity, right? So the properties of chi-square distribution is not symmetrical distribution, right? It's not symmetrical distribution because it's a skewed distribution. It range from like 0 to infinity. There are no negative value. The total area under the curve, so the total probability, the area of the curve is still equal to 1. It still hold the properties of probability. The degree of freedom for chi-square analysis is number of row minus 1 multiplied with number of column minus 1. So this is indicated as the degree of freedom is number of rows minus 1 multiplied with number of column minus 1. So this is how we calculate degree of freedom for chi-square analysis, right? So there are some assumptions that we need to test in order to use a chi-square distribution or chi-square Pearson chi-square analysis. This is another name for chi-square independent test is a Pearson chi-square test. So Pearson chi-square test or chi-square test of analysis is a non-parametric statistical method, which does not require any normality assumption because the distribution itself is not normally distributed. It's not symmetrical. It's a skewed distribution, right? So the data should be randomly selected. This is the second assumption. All the expected value, expected frequency or expected value must be greater or equal to 1, right? Must be greater equal to 1. So means that the expected value should be greater than or equal to 1. So the total expected value or expected frequency that less than 5, right, should not more than 20%. So the total expected frequency expected frequency less than 5, right? Should not more to not more than 5, right? It means that it should less than 5, right? It should less than 5. Then if the expected value is less than 5, then we can use Pearson chi-squared test of independence, right? So the calculation of chi-squared statistics. So now if you know in a t distribution, the calculation of t distribution t-test is x bar minus mu divided by s over square root of n. For z distribution, x bar minus mu divided by sigma over square root of n. But for chi-squared analysis of independence, this is the symbol for chi-squared, x square. The formula will be the summation of observed value minus expected value, and then we take the square for this value, right, for each observation, and divide by expected value. So then we take the summation for all observation. So this is what we call as, this is the formula for chi-square distribution, right? Then since we are talking about expected value in the assumption, right, expected value less than 5, should not more than 20%, right, should not more than 20%. I think this is wrong. This should be 20%, right, 20%. So since we are talking about expected value, so to calculate the expected value, row total multiply with column total divided by grand total. This is the formula for expected value for each cell, right? So remember, we are talking about qualitative variable, two qualitative variable. In two qualitative variable, usually we are presenting the data in a cross tabulation table. So normally cross tabulation table consists of rows, right, and column, right? So in the number or observation in this value and this each cell, we call as a frequency value, right? The frequency value lah, right? So hope you understand, you know how to construct a cross tabulation table already, right? So now the hypothesis testing step. So the step are still remain the same as previous step. First step is we need to specify the null and alternative hypothesis. The second one is we need to know what is our level of significance. And then the third step is test statistic, which is we are going to use a chi-squared test statistic of independence. And we're going to make a decision rule. If you are using a critical value, right, then if the calculated chi-squared value lies under rejection area, then null hypothesis will be rejected, right? If you are using p-value approach, right, when the p-value is less than alpha, then null hypothesis is rejected, right? And then step number 5, we will make a conclusion and interpretation of the result in the context of the problem, right? So next, move to example number 27. So I'm going to show you step by step how to construct a hypothesis testing for chi-squared analysis of independence. So now look at example number 27. So the following data represent the preference of food according to gender. So preference of food according to gender. So we have two variables here. This is variable number 1, preference of food, and according to gender, this is the variable number 2. So the question asks us to carry out a test, 5% level of significance, to determine whether there is any association between gender and preference of food. So as usual, they should give us the cross tabulation table. So this is a cross tabulation table. We have food in a row and gender in the column, right? So we have three columns, three rows, right, and 2 columns. So first step, let's try to fill in the value that missing in this table. So let's focus on count, right? Let me highlight this one so you can see clearly, right? So this is the value that we want to fill in first. So 40 plus 20 should be equal to 60. This is the total for Indian food. Total for Japanese food is 70. Total for Western food also 70, right? So then we need to find total for male. For total for male is 110, right? And total for female is 90. So the total, this is what we call as grand total. So the total for whole observation is 60 plus 70 plus 70 should be equal to 200. 110 plus 90 should also equal to 200. So next step, we need to calculate the expected value. So this is the expected value. Remember the assumption of chi-square analysis. The expected value less than 5 should not more than 20%. So now remember the formula of expected count, expected value, or sometimes we call it expected frequency, expected count, expected value. It's the same definition, right? So row total multiply with column total divide by grand total. So this is what we call as a row total, the green value lah. This one is column total, right? So let's say I put this one as A, B, C, D, E, F. So let's calculate for A first. Row total for A is 60. Multiply with column total for A is 110. So if you confused, let me clear out this one, right? So we can see clearly. So the total for row total for A, column total for A. So it should be 110 lah. Divide by grand total. Grand total is 200. So then we need to calculate lah the expected frequency. And this one should be 60 multiply with 110 divide by 200. So it should be equal to 33. So equal to 33. And B, right? B is, let me clear this one. So row total for B is 60. Column total for B is 90 divided by 200. Right? Later on we will do a calculation lah. And then for C, row total for C is 70 multiply with 110 divided by 200. For D, 70 multiply with 90 divided by 200. For E, 70 multiply with 110 divided by 200. And F should be equal to 70 multiply with 90 divided by 200. Right? So now we do a calculation lah. So for B should be 60 multiply with 90. Right? Is equal to 27. Right? And then for C, 70 multiply with 110 divided by 200 should be equal to 38.5. And then for D, it should be 70 multiply with 90 divided by 200 should be equal to 31.5. So this one is same as this one, should be 38.5. This one same as D, this one is 31.5. So then once you already got the value, we just plug in the value inside the table. So let me plug in the value inside the table. So this one should be 33, and B is equal to 27, C is equal to 38.5, and this one equal to 31.5, and this one should be 38.5, and the last one is 31.5. Right, so I'm going to erase the calculation. Oh no, I think I don't want to erase the calculation. I'm just going to make it smaller and put aside. Right, I'm going to put aside somewhere here. Right, so then the next step is we're going to construct a hypothesis, because the question asks us to carry out a test at 5% significant level, determine whether there is a association between gender and preference food. So hypothesis statement. So our hypothesis statement, null hypothesis, there is no association between food preference and gender. Right, for an alternative hypothesis, there is an association between food preference and gender. And then this is step number 1. Step number 2 is our significant level. Significant level alpha is 0.05, because we want to test at 5% significant level. And then step number 3 is test statistic. Our test statistics, we're going to use a chi-squared analysis, which is summation of observation minus expected, and then you square divided by expected value from I equal to 1 until n. So now we already have the observed value. So observed value is actually the frequency value lah. So this is what we call observe 1. So this is a cell number 1, cell row number 1, column number 1. And this is observe 1, 2, observe 2, 1, observe 2, 2, observe 2, 3, 1, observe 3, 2. And this value is expected 1, 1, expected 1, 2, expected 2, 1, expected 2, 2, expected 3, 1, expected 3, 2. Right, so we know the value of observed and expected. So now to make it clear and understandable, so let's draw a table, right, to calculate all the value required for chi-squared analysis. So let's say I divide it into gender and food. Right, so gender starting with male, food we have Japanese, we start with the Indian, right? Indian. So let me use the standard color red, Indian. And then after Indian we have Japanese and Western. Japanese and Western. Right. And for female, we still have the same food preference, Indian, Japanese, Western. Right. So we have observed I and expected I. So observed value and expected value. So the observed value is, let me put it the value here. This is 40, Indian, for male 40, 20 and 50. right? For female is 20, 50 and 20. 20, 50 and 20. 20, 50 and 20, right? So the expected value, so the starting one is 33, 38.5, 38.5. 33, 38.5, 38.5. For female is 27, 31.5, 31.5. 27, 31.5, 31.5. So this is the value I copied back from the original table. From the original table, we have a 2 by 2 or cross tabulation table. So I rephrase the table into a long format. So the reason why I rephrase the table to long format or convert the table to long format, because I want to have this calculated value, which is the first value that we want to find is observed minus expected. So the observed I minus expected I, right? So then 40 minus 33 should be equal to 13, right? And 20 minus 38.5 should be equal to negative 18.5, negative 18.5, right? So 50 minus 38.5 should be equal to 11.5, 11.5. So this one is not 13, it's actually equal to 7. Sorry, I miscalculated here. So this one should be 7. Right, 20 minus 27, it should be negative 7. So 50 minus 31.5 should be equal to 18.5, and 20 minus 31.5 should be equal to negative 11.5. So now we have the value, but in this formula it should square by 2, right? Power by 2. So observed minus expected, right? Square, right? So this one should be 49, right? So neg 18.5 power of 2 should be 342.25, right? Let me write it properly. 342.25, 11.5 squared should be equal to 132.25, 132.25. This is 49, this is 342.5, this is 132.5. So now we need to calculate the next one, which is observed minus expected squared divided by expected value. So for this value divide by the expected value here. So 49 divided by 33 should be equal to 1.48, 1.48. So let's take 2 decimal point, right? Another one is 342.25 divided by 38.5. It should be equal to 8.89, 8.89. And next one is 132.25 divided by 38.5 should be equal to 3.34, 3.44, And then 49 divided by 27 should be equal to 1.82, 1.82, right? And then the next one is 342.5 divided by 31.5. It should be equal to 10.87, 10.87. And the last one is 132.5, oops, 2.5 divided by 31.5. It should be equal to 4.2, 4.21. Right, so we have all this value. So the condition of chi-square is the summation of all these value, right? So the summation of all this value is a chi-square value. So we need to add all the value here, which is 1.48 plus 8.89 plus 3.44, 1.82 plus 10.87 plus 4.21. So this one should be equal to 30.71. 30.71. So this is the value of chi-square, right? So we already have the test statistic value. So we have a test statistic value, which is chi-square is equal to 30.71. So the next step is we need to calculate the critical region. So the critical region, remember the chi-square distribution is skewed to the right distribution, right? It's starting from 0 to infinity. So let's say we want to find 5% level of significance. So this is going to be 5%. Also indicate as a rejection area, and this is what we call acceptance area, right? So we want to find this value, which is what we call as critical value. So the critical value is a chi-squared alpha with degree of freedom. So our degree of freedom here is number of rows minus 1 multiply with number of column minus 1. So number of row, look at the cross tabulation table, we have 3 rows and 2 columns. So degree of freedom will be 3 minus 1. This is number of row minus 1. Multiply with number of column is 2 minus 1. So this one should be equal to 2 multiply with 1 equal to 2. So degree of freedom is equal to 2. So the chi-squared that we want to find is 0 alpha 0.05 with degree of freedom equal to 2. So now we're going to look at the statistical table. So the statistical table, you can go and find the statistical table, table number 8. So in table number 8, there is a chi-squared distribution statistical table. So before we read the table, right? So look at the distribution that they draw. So they draw distribution on the right hand side. So this is what we call as our alpha. Right, this is the critical value. So our alpha is 0.05 and degree of freedom is V. V is equal to 2, 0.05. So the value of alpha chi-squared 0.05 with 2 degree of freedom is 5.911. If you can see here, right, 5.991. So we know that this is 5.991. Right, so next we need to put our decision rules, right? Decision rules. Let me make it bigger. So our decision rule, if chi-squared calculated, right? Calculated means that we are this value, this is a chi-squared calculated, right? Chi-squared calculated. This is based on this critical value approach. If chi-squared calculated lies in rejection area, null hypothesis is rejected. Right, and otherwise, if chi-squared calculated lies in acceptance area, null hypothesis is accepted. So our decision is, since chi-squared calculated is equal to 30.71, which is lies inside rejection area, so null hypothesis is rejected, right? So we reject null hypothesis, and conclusion is we can conclude that there is an association between food preference and gender, right? So this is how we make a hypothesis testing for chi-squared in level independent, right? Chi-squared test of independence. Okay, so I hope you understand, right? Alright, for example number 28, I think the same process. I leave it for you to try it by yourself. Please try to solve this problem and conduct a hypothesis testing to determine whether the gender and social class are associated or independent, right? So you can test by yourself, you can conduct your own hypothesis testing. So first step is you need to complete this table and state the hypothesis statement, level of significance, test statistic. Then you need to create a new table, right? So new table is this one, this table lah. Where is this table? This table, right? So you need to create this table so then you can understand the process of calculating the chi-square analysis of independence. And then the procedure are same, but the difference is in critical region. In critical region, you need to take point that distribution is skewed to the right distribution, starting from 0 to infinity. Find the value of critical region, critical value, and then you can make a decision and conclusion as usual, right? So example number 28, I leave it for you to do it by yourself, right? So now we're going to look into a chi-squared test of independence using a SPSS output. So in SPSS output, they will give you two tables, right? The first table is the cross tabulation table. Another table is a chi-squared test, right? So now let's look at the cross tabulation table in SPSS output. So the first table, cross tabulation table, right? And the first, for this table, you can see there is a row. Row is for food preference, right? For Indian, Japanese, and Western. And each row they have a count, which is a frequency, and expected count, expected frequency lah. And then we have a gender for representing the column, right? And each at the end of the column, right? So we have total, the total for each count and expected value lah. So this is the value of 110 is the value of frequency total for column. This is total for female, and this is the row total. So the expected value or expected count is get from summation of ataupun row total multiply with column total divided by grand total. So this is the grand total. So 60 multiply with 110. So 60 multiply with 110 divided by 200 equal to 33. So this is how we get the result, same as calculated earlier. So next table is we have a chi-squared test table, right? Chi-squared test table. In this chi-squared test table, there are a lot of tests given in SPSS, such as Pearson chi-squared test, likelihood ratio, linear by linear, association, and valid cases. So as I mentioned just now, if we are using a test of independence, so usually we are using Pearson chi-squared test. So if the in the chi-squared test, remember the assumption, there are 4 assumptions, right? So one of the assumption is the number of expected count less than 5 should be less than 20%. So in SPSS, they already give us the indicator. So there are 0% of expected count less than 5. Means that there are no expected count less than 5 lah, which is good, right? If their expected value, the percentage here shows more than 20%, then we cannot use Pearson chi-squared. Right? You should use other tests such as the Fisher exact test, likelihood ratio, and so on lah. Right? So the minimum expected value is 27. So the SPSS already give us the explanation of the minimum expected value from the cross tabulation table. So this is the value of chi-squared test that we already calculated earlier. So from our manual calculation, we got the expected value is 30.71. This is due to the correction of decimal point lah. Huh? So if you are calculating using a machine or computer, right? So you should get 30.68 lah, as we got from SPSS, right? 30.688, right? So since we are calculating manually, and this is due to our decimal point calculation, so we got 30.71. So this is the degree of freedom. So degree of freedom is getting from row total, number of row minus 1 multiply with number of column minus 1, right? This is a p-value, right? Usually in the newer version, they will not show p-value 0.00. They will show less than 0.001, right? So this is the correct way to present the p-value instead of putting the value only, right? So now if you are using the tadi kita tengok using critical value approach, right? So if you are using p-value approach, so since the p-value is, this is not less than 0.001, right? It's less than 0.05, which is our alpha. So then we will reject null hypothesis. If this p-value less than alpha, which is our 0.05, right, or 0.01, so then we will reject null hypothesis, right? So we don't need to divide this p-value by 2, right, for chi-squared test, because this is already calculated for chi-squared test, right? So now I'm going to show you how to get this result from SPSS. For example, let's say I already key in the data for the data in SPSS. So I have 2 variable, gender and food, right? Food preference. To get the cross tabulation table and chi-squared test of analysis, so we just need to go to analyze and click on descriptive statistics and find cross tabs. So analyze descriptive statistics and click on cross tab. So once you already click on cross tab, right, so you will get this dialog box, and on the left hand side is your all the variable available in your data set. So in right hand side we have row and columns. So we put the variable in rows and the variable in columns, right? And then we click on statistic. right? Once you click on statistic, so you will get another dialog box. We just click on chi-square test, right? Chi-square test and click continue. And for cell button, we click on cell button, we will get this dialog box. By default, the count is already ticked for observe. We need to check for expected, right? Since we want the value of expected, we need to check for expected and click continue, right? And then click OK. So once you click OK, you will get this table. So basically, SPSS will give you three tables. The first table is a case processing summary to show how many cases are valid, how many missing variable, how missing value. The second table is about cross tabulation table. This is the same table that we got from here, right? It's the same table, and then we will get the value of chi-square table, right? So it's the same table. So notice that for a newer version, this is a version 28, IBM SPSS version 28. So the p-value is no longer state 0.00. It will show less than 0.001, right? So this is a newer version, right? This is a correct way to present the table, the p-value, right? So I hope you understand. So if you don't understand, you can replay back the this lecture video, right? So now let's look at example number 29. So a statistician is interested to investigate whether the travel package offered by Lina travel agency dependent on the type of family. So we have type of families and travel package. So travel package we have basic, premium, plus, and for type of family single and nuclear, right? So there are value that not computed in this table, right? So now they ask us to compute the value of A and B, right? So to compute the value of A is very easy, right? A is a expected count, right? Expected count for A is row total is 396 multiply with column total, right? Column total is 281 divided by grand total 764, right? So this one should be, let's say, 396 multiplied with 281 divided by 764. It should be 145.65, right? So since they are using single point, should be 6 already lah, 6 only or 7 lah, 145.7, right? So to calculate value of B is then we need to create a table lah. We need to create a table to calculate value of B. So I'm not going to proceed with the table, but I'm going to show how we're going to create a table. Right, this one should be type of package, a travel package. This one should be travel package lah. So we can easy to copy the table to long format. This is travel package, and then we have type of family. So travel package we have basic we have basic we have single and nuclear. Same goes to premium. We have single and nuclear, and the last one here we have plus single and nuclear as well, right? And then baru kita masuk the value of observe and expected, right? And then we have observe minus expected, right? And then observe minus expected square, and the next one, the next column should consist of observed minus expected square divided by expected value, right? So then baru kita boleh cari the what we call the total value, right? So it's easy to key in now, right? This is 131, 135, 98, 119, 139, 142, and this one should be 128.1, 104.5. Sorry, this is wrong. This is 137.9. This is 104.5, and this is 112.5. This is 135.4. This is 145.7, right? All right. So then we can calculate the difference between these two, right? So the first one 131. So let me use my own calculator lah, 131 minus 128.1. This one should be 2.9. This is 2.9. 135 minus 137.9, negative 2.9. 98 minus 104.5. This is negative 6.5. 119 minus 112.5. This is 6.5. 139 minus 135.4. This is 3.6. 142 minus 145.7. This one should be 6 lah. Should be 6. This is negative 3.6. 142 minus 145.6. Right, 3.6. Then it should follow the sequence lah. So 2.9 power of 2 should be 8.41. This is 8.41. 6.5 square is 42.25. 42.25. This is 3.6 square, 12.96. 12.96, right? And then this one, this value should be divided in with this value, right? So we will get the value of chi-square. So 8.41 divided by 128.1. It should be 0.06565, right? So 8.41 divided by 137.9. This one should be 0.06098. So how many point we got? I think I'm going to get until 4 decimal point lah. 4 decimal point. So this one should be 7. And this one should be 10 lah. 10. Right? And then 42.25 divided by 104.5. It should be 0.4043. And this is 42.25 divided by 112.5. Should be 0.3756. And 12.96 divided by 135.4. It should be 0.0957. The last one, 12.696 divided by 145.6. So this one should be 0.0890. So the total here should be equal to, you need to total up all this one. So 0.0657 plus 0.0610 plus 0.4043 plus 0.3756 plus 0.0957 plus 0.0890. So this one should be 1.0913, right? So the value of B is 1.0. B is go to 1.0, right? 1.0913. A is equal to 145.66 or 1.6 lah, right? So state the hypothesis testing to test state appropriate test hypothesis to test the package dependent. This is a chi-square test of independent, right? So based on the p-value, can you conclude that about the claim? So the claim is there is the travel agency depend on type of family. So the travel package type depend on type of family. So see the p-value is 0.577. Since the p-value is more than alpha, which is 0.05, null hypothesis is accepted. So what is a null hypothesis for this this is question B. State the appropriate hypothesis, right? So this is the test that we want to use. The appropriate hypothesis is there is no, so we can say that, in other words, we can say travel package is independent. So travel package and type of family is independent, and type of family is independent, right? Alternative hypothesis, travel package and type of family is dependent, right? So since for C, right, so since null hypothesis is accepted, we can conclude that travel package and type of family is independent, right? So this is how we answer the question lah. Okay, so we have a lot of example here until example number 36, right? So I'm not going to go through every example, right? I'm going to pick another one example. Let's say I'm going to use example. This example is the same as previous example number 29. You can do it by yourself. This example 31. So I don't think I want to finish up example number 31. So I think you should for example number 30 until example number 36, you should do it by yourself, right? If you have any question, then you can ask me in a WhatsApp group, right, or text me personally to ask the question. So but before that, I want you to do it by yourself, example number 30 until number 36, right? So that is going to be your exercise, take home exercise, right? I think that's all. If you have a question, then please write it in chat room, Right. I think then, and we will continue on the next topic, which is um, one-way analysis of variance. So this is going to be our last topic for chapter hypothesis, right? So I think that's all. Thank you very much. Assalamu alaikum.